Hello together. Yeah. We have some problems because in our company we about a computer, and this is why I traveled here to UK directly and have the presentation for you. Yeah. I'd be happy to have another presentation on this WebEx, yeah. And I will show you today the surfaces or the roughness on the surface and the cylinder bore. I will share now my screen and then you can see it and then we can start it. When you have any question, please be so kind and write it on the chat. And Rod, he will look what it's your question and then he will interrupt me. Okay, now I will share the second, please. I hope you can see my presentation, cylinders surface roughness. And what I will show you today, I will just start with the one slide, the road to 95. This is the biggest information what the government in Europe say, and also in Germany. We will drop down the CO2 per kilometer from 120 gram to 95 gram. And this is a big job for the engineer department, how they can do it to drop down the CO2 per kilometer on the gasoline and also for the diesel engine. The engineers, they look what they can do it on the combustion engine that drops down the CO2 per kilometer, and different points they started. They started with downsizing, reduction friction, weight reduction, and hybrid system, emission control, and. But we will focus today on the reduction friction. Reduction friction on the bearings and especially reduction friction on the surface of the cylinder bore. When we speak about reduction friction, then we must test it. How big are yes, I would say roughness and all this, what they design new in an engine, and they have friction tests. How big are the friction, especially on the liner and piston rings and also on the cylinder surface. This is a friction test. This is a special engine what we have in our company by KS, and then we can test it, how it's the friction when we change the tension of the piston rings, when we change the oil, when we change the roughness from the surfaces from the cylinder bore. Or we have a long life test. Long life test means we have a test more than 600 hours engine is running. What is the result when we change the roughness of the surface on the cylinder bore? When we speak about CO2 reduction, then when we see it here, the piston ring package of the cylinder sliding surface, it's 3.3 gram. This is one of the biggest point that we can reduce the CO2. And this is also why all the companies, they build and design engines, Mercedes, BMW, MAN, and so on, not only in passenger car, also in the truck applications. They have a big focus on the cylinder sliding surface. And this is also why in the past, I will say in the last 5 years, there was a big change on the cylinder sliding surface. And this is also why we have a focus on it, and what you must have also a focus on it when you overhaul an engine and when you drill it out a cylinder bore, make an oversized piston, or also when you hone this cylinder bore in the oversized area. When we look on the surface parameters and we see it here on this page, we have a big different information of surface parameters. RSM, RZ, RQ, VT, RVK, RPK, and so on. A lot of different measurement points you can measure, but when we speak about and we are concentrated on the surface of the cylinder bore, then we concentrated only on 2 points, the RVK and the RPK. These 2 parts of measurement points are the importance that you see how good are the surface. How good are the surface and the roughness? How good are also the surface about of oil consumption maybe? Because of these 2 parts, you must check it when you overhaul the engine, when you drill it out, when you honing again the surface. When you see here on this page, then I will describe what it's a RPK and what it's a RVK and a RK in these different points. You see here some of a profile of a measurement from a tool. They measure the surface. And you see the RPK on the top of the peaks. The RPK are the roughness, what you can feeling when you go over the surface. These are the peak of the hills, I would say. The RVK, this is how deep are some grooves inside in the surface and how big are this groove? How big are the volume of this groove? And this is important also, the RVK, it's important how much oil they can, in this area, in this volume, contact the surface, and it's there when the piston ring runs up and down. And in this situation, the piston rings, they need oil to sealing in this area, and they take out oil from this area, from the RVK area. And this is why it's also very, very important that when we create or when we hone a surface, that we must create some deep groove inside in the surface. This is for the oil volume. It's very important, RVK. The RPK, it's the top of the hill. That means in the past, maybe 10 years ago, the RPK was very high. There had a lot of peaks on the hill. And then in this time, we have a minor piston ring inside. And then we need also a running in effect on our engine, 10, 15,000 kilometers. And in this time, the minor piston ring remove the peaks on the hill, the RPK, and reduce it. Now, in this time, now when we speak from the next generation of engine, the RPK are very less because of a honing process. We cutting this top of the hills, and we make in the process of the honing process this running in process before you install the piston. And then we don't need this running in process because we machine it before and cut the peaks on the RPK. You see also on the right side, you see the yellow parts, the A1 and the A2. These are the peak area and the value area. This is MR1 and MR2. Also, when you measure the roughness on the surface, this roughness test tool, they give you the MR1 and the MR2 on the information. And these are also important, how big are the area, the peak area is the A1, and how big are the volume area for the oil, it's the MR2. When the MR2 very small, then give me the information that we have not enough place, room, volume for the oil. When the MR1 are very high, then we have a lot of peaks on the surface on the top. And we have, I will say, a rough area on the top, and we have also a little bit more wear on the piston rings, because the piston rings remove the peaks when we don't do it before with the honing process. Here again, the surface parameter, the RZ and Rmax. In the past, the surface, it's measured in the RZ and the Rmax, and this gave in the past the information how good is the surface, how good is the parameters of the surface. This is now not so much important. You see the RZ1, and the RZ1 is the information how big are the biggest point on the top of the hill of the roughness and to the bottom side in the groove. The RZ max and the RZ1, it's one peak on the surface, and the RZ2 is the second peak, RZ3 and 4, 5, 6. How long is the measurement tool it's running on the surface? This is the LN. It's how long you measure the surface. The Rmax gives the information from the highest top to the lowest groove position. This is not so important for us. Important more, it's the RVK and the RPK. This is the information for you. Here you see also the measurement tool, the RA. It's, I will say, the roughness on the length when you measure it, and then the middle calculation. It means roughness A is the arithmetic of the amount of all the profiles. And this is also information how good is the arithmetic, I would say, roughness of the surface, but it's not the information, the right information for people. They take the honing machine and take the surface with the honing machine, with the honing stones. More information and a better information, it's the RVK and the RPK, what I told you before. Here again, the core roughness RK, it's the arithmetic middle point, and the RPK the top, the RVK the bottom side. And here again the MR1 and the MR2. The reduced value of the RVK is the erasure deep in the values. This is what I said. The RVK, it's necessary for the oil capacity, the oil volume on the surface. The RPK, the top of them, the RPK, it's the top of the hills, and how good are the surface, how rough the surface, and how rough the surface that's running the piston ring on it. And this is necessary also for the wear for the piston rings. Here, it's an overview what it means 1 micro. When we speak about on the roughness, we have micro. You see the yellow part. This is a paper clip, and this is 0.8 micro. Millimeter. A pig hair, it's 0.1 millimeter. A pin, it's 0.6 millimeter. A newspaper, it's 0.08 millimeter. On the left side, you see a cigarette paper. This is 0.8 millimeter. A human hair on your head, it's 0.05 millimeter. And from a spider, the silk, it's 0.006 millimeter. And 1 micro, it's less than silk from a spider. It's 0.001 millimeter. You see nothing. This is not this yellow point. This is a point, and you cannot see it. So small is it, 1 micro. That means that you feel feeling how big it's 1 micro. It's nothing. And you cannot measure, or you cannot measure with different tools. You cannot measure, and you see some different tools on this slide, with a micrometer, with a loop or other things. This is too small. You need a roughness tester. You need a special tester. They can test this very small surface. And I don't know how you measure it in your company, in your garage, in your workshop, the roughness after when you make the honing process. I had a presentation in Germany by German reconditioners, and I also asked this question, how you measure this? And they gave me the finger and say, I measured with my finger. I go in the surface with my finger and then I say, yes, it's a good roughness or a bad roughness. Yes, you have it maybe in your feeling in your finger, but you cannot say, is it 0.01 micro? Is it 0.1? Is it 1 micro? You don't say it. You need a measurement tool that you measure the roughness. Then you see you are in the green line, what the company need, the surface roughness, or you say, okay, I have no tester, I don't know exactly. The information also for you, when you don't have a roughness tester, the older generation of engine, maybe engine 25 years old, this will be not maybe a problem. And I know it, that you have a good feeling on the honing machine. And it's very well, maybe they have no oil consumption. But a new generation of engines, maybe when we speak from downsizing engine, when we speak from a hybrid car with a small engine, a 3-cylinder, twin turbocharger on it, and are the new generation of engine. They will have some different problem, and also you must be careful when you overhaul this engine, and also be careful when you drill it out and you make a honing process inside the surface. They must be in the right line. When it's not in the right line, they can have problem, maybe oil consumption and other things. This is why it's necessary that you have a roughness tester. You cannot only test the roughness on the cylinder bore, you can also test the roughness on the surface. There's the gasket, and this is also very important with the new generation of the gaskets. Here you see the top of the needle from a roughness tester. This black area, the small pieces here, this is a diamond, and this is very, very small. And this diamond, it's moved on the surface, and take the surface roughness and give the signal inside in the roughness tester that you can see later, the RPK, the RVK, the RA, and so on. And they calculate it inside in this roughness tester. Here you see again a small measurement variables, the RA, the RZ, the RPK, the RK, and the RVK. And also on the rear side, you see on the right side, reduce values, deep, the RVK, the RPK, it's the peak highest part on the surface, what I told you before. And here, this is describe all this. Also, when you look in our homepage from MSI, Motor Service International, there you will find a flyer or you will find a poster, and there is also described this again, and you can download it in different languages. Here, it's an overview of the guides of the roughness values in the practice. This is not coming from my side, not coming from KS. This is coming from a company also together, what I worked before together with them. This is coming from Firma Nagel, or it's coming from other companies. They produce honing machines. You see, I concentrated here again on the RPK and the RVK MR1 and MR2. And you see 0.1 to 0.4 micro on the passenger car, petrol car, it's the RPK. On diesel truck, I will say, bigger engines, it's 0.2 to 0.6 micro. This will be the value what the OE production produces in the generation in the generation of the engines what they produce it now. The RVK 0.5 to 1 and 0.5 to 1.5 for bigger engines, for diesel engines, petrol for maybe for the truck applications. You see, this is a little bit higher, and the RVK that on the passenger car. For the bigger engine, we need a little bit more volume for the oil capacity. And also the MR1, 4 to 12 on the passenger car, petrol, diesel, and 4 to 10 on the application for the bigger size. And also 75 to 90% MR2, passenger cars, petrol, diesel, and for the bigger engines, 80 to 90%. Also, this values, this is calculated the test itself, and then you can see this different parameters. The angle, the last one, 25 to 45 degrees, and 40 to 60 degrees on the bigger engines. This is the older version. The new generation have different angle, but I will not tell it here in this presentation. But normally 40 to 60, this is the right angle what you produce in the honing machine, and then you are sure it's working. When you are not sure of this engine, what you overhaul, and you are not sure what value you must have it, what you see it here again, 0.1 to 0.4 in the RPK or in the RVK or RZ, then you can measure on the bottom side of the cylinder bore, and there normally are not moved the piston rings, and you have the original surface roughness. And here, when you go with a roughness tester and you test it, the roughness, then you see which roughness was on the original engine, or when they build an engine, the new engine, and then you can create the honing process, or you can adjust the honing machine that you have very close to this roughness values, also after the finish the honing process. Do you have any question to me?